Welcome to our Wetland Institute speaker series on wetland monitoring and maintenance. Before we begin, I just wanted to take a quick opportunity to thank our sponsors. Without their generous support, we would not be able to offer these events at no charge to our participants. So I'd like to thank Environment and Climate Change Canada, the Province of British Columbia, Habitat Conservation Trust Foundation, and Wildlife Habitat Canada. I'd also like to respectfully acknowledge that we are hosting this webinar on the traditional territory of the following First Nations. So the BC Wildlife Federation office is located in Surrey, which is the traditional territory of the Coast Salish peoples, including the Keetsi, Coquitlam, Kwantlen, Kikite, Tsawwassen, Stolo, and Musqueam First Nations. And our guest speaker today, Elke, is joining us from Nanaimo, which is the traditional territory of the Shinaimau, the Snanawas, the Chemainus, and the Mid-Island Métis Nation. Before we get going, this format is a little bit different than our regular Wetlands Institute. So due to COVID-19, we had to switch gears a little bit and offer virtual learning opportunities. Usually our BCWF's Wetland Institute is an intensive 7-day hands-on workshop that educates participants about wetland stewardship, restoration, and construction. It includes in the field learning to practice up-to-date field techniques, and participants usually gain practical experience restoring or enhancing at least one wetland. There is limited seats to apply, and participants do apply to attend, and they must have a wetland related project in mind, either restoration, protection, enhancement, or an education project. It is free to BC residents, and we value this workshop at over $1,000. And every participant that comes through the Wetland Institute receives up to 3 years or more of post-workshop support to help complete their project within their community. We do anticipate offering a hybridized version of the Wetlands Institute next year. So all of our classroom portions will be virtual, but all of our hands-on portion will be in person. And we will be accepting up to 15 applicants. So if you're not already on our mailing list, please do so. So you'll receive firsthand information about the Wetland Institute applications being open and joining us for this amazing opportunity next year. So just a few housekeeping things to set you up in our Zoom webinar. So please only use the chat icon for technical questions regarding Zoom, and then use the Q&A button for guest speakers, and we'll save your questions for the end of the guest speaker presentation. Molly will be keeping an eye on the Q&A panel, and she will ask the questions on your behalf. And without further ado, I'd like to introduce our guest speakers. So first we have Elke Wind, who is a registered professional amphibian biologist and founder of Wind Consulting. She has focused on conservation, assessment, and management of amphibian populations and wetland restoration and construction for the last 20 years. And Elke will be speaking on amphibian monitoring, trapping in the field, and sharing a case study on an amphibian monitoring project to help influence local legislation. And Neil Fletcher will also be speaking today. So he is the manager of conservation stewardship at BC Wildlife Federation. He's been working in the wetlands education program for over 10 years. And through his work across British Columbia, Neil brings a wealth of experience and knowledge about wetland conservation and restoration. And he will be speaking on a post-restoration monitoring study that we conducted in 2018. So without further ado, I would like to introduce Elke, and feel free to share your screen.
Great. Thanks very much, Alyssa. All righto. There we go. Everyone can see that all right? Great. All righto. So today, go back up. I'm going to be talking about why landscape context matters in wetland conservation. And thanks very much for letting me speak during the Wetlands Institute. I'm always really happy to be part of this program. I'm going to have 3 general areas to the talk, an introduction in terms of what landscape is for an amphibian, and then I'm actually going to go through 2 case studies. The first one is forestry and frogs, and the second one I'm calling roads and toads. So what is landscape from an amphibian perspective, and why does it matter? We have 20 amphibian species in British Columbia, and 65% of them, or 13, breed in standing water habitats, so ponds, lakes, and wetlands. We've had pretty significant population declines of amphibians. About 32% of amphibians around the world are threatened with extinction. And as for most wildlife, habitat loss and degradation are considered the major threat, but they're also facing a number of other stressors associated with pollution, invasive species, and disease. Amphibians are a unique taxonomic group. They require moderate, moist climatic conditions for a number of reasons. Primarily, they have semi-permeable skin, which means they're very susceptible to drying and to any sort of chemicals within the air, on the land, or in water. And because of the semi-permeable skin, they're very closely tied to moist microcytes. So they're often hanging around in vegetative cover, under or in downed wood or underground, in order to meet this moist requirement as well as moderate temperatures. So what is landscape for an amphibian? Let's look at where they are at different times of the year and what they're doing. So starting on the left side, at the beginning of the year, they're coming out of winter dormancy. They're not true hibernators, but they're in some sort of a winter dormancy or torpor. And then they're emerging in late winter to early spring, depending on where you are within the province and what species we're talking about. And they're migrating to breeding sites. So these adults are making a migration in early spring, late winter, to lay their eggs. And then you have eggs and tadpoles or salamander larvae developing within that water body throughout the spring and summer. And then those metamorphs by mid to late summer or up until September will be dispersing into upland areas. And then all of those individuals that are in upland areas have to migrate to winter hibernation sites. So the timing of all of these things varies by species, geographic location, and then the year, so the climate with any given year. But what's important to notice here is that for some species, they're spending up to 10 to 11 months of the year on land. So they're really only at that aquatic breeding site for the breeding period and then for the egg and larval development. The majority of our native species, as I've just mentioned, are breeding in water and then spending most of the year in these terrestrial environments. So a lot of our amphibian species require at least a year, and some of them up to 5 years before they actually reach sexual maturity. And then they'll return to this home water body to breed. So they're wandering around on land, sometimes for up to years, and then they're actually managing to come back to that same pond or lake or wetland to breed. So amphibians are very faithful or philopatric to their breeding sites, but studies are also showing through radiotelemetry that they're also returning to their summer home ranges and then potentially also to overwintering sites. So they're very aware of where they are within the landscape and they're revisiting these same habitats. Therefore, most species are very dependent on both aquatic and terrestrial habitats, and they need to be able to move freely between them on a seasonal basis. Amphibians live in what are called metapopulations, and this is local populations that consist of a number of subpopulations. So what we have within a landscape are a few what we call consistent breeding sites. So they have low but predictable breeding success. And often these are larger water bodies where they're often living with or in relation to other larger predators such as fish. So the populations are generally kept at a relatively low level, but they're consistent, they're wet all the time, and they can have some sort of reproductive output. But then you have a number of smaller wetlands that are seasonal. They may dry every year, they may dry in some years. And when we have a good year in terms of climate, they can have almost like a bumper crop of young coming out of these smaller sites. And these more opportunistic sites are very important as well. So all of these subpopulations or breeding sites within the landscape are all interconnected. So it's not about one particular wetland or pond as a population. All of these wetlands and lakes together are considered the actual population. And small, often ephemeral wetlands are used for more than just breeding. They're used for foraging, cover, hydration, and possibly as stepping stones for individuals to be able to move throughout the landscape, especially when it's a drier, hotter time of the year. The overall success of a species is dependent on this annual interconnected population fluctuation across all of these different types of wetlands. Unfortunately, our protection is very selective. Our riparian buffers and wetland protection are based on wetland size or to meet fish management objectives. And then on top of that, what we do is we isolate populations. We remove permanent forest cover, we build roads, and we drain and fill wetlands. So what happens is we end up with these wetlands with just this little donut buffer around the water body, but the upper landscape, the surrounding matrix, is not taken into consideration. So given that background, we'll go into the first case study, which is our forest drain frogs. And this study here is something that's been going on since, it started actually way back in, pardon me, around 2002. And we've just had a recent repeat field season in 2020. So I'd just like to acknowledge the people that were involved in this year's work and the funders. So let's go into the study background. Timber harvesting has often been cited as having a negative effect on amphibian populations, but the results are somewhat inconsistent and they vary by species and geographically. So you can imagine a lot of the studies that I've read, they've come from Northern California, in Oregon, in the southeastern United States, where conditions are quite different. We have much longer, hotter, drier summers in those areas compared to British Columbia. And the studies have often focused on populations in terrestrial environments or on stream breeding species. In British Columbia, it's important to note that small isolated wetlands are not afforded any sort of riparian protection. So here on the coast, anything that's less than half a hectare doesn't require any sort of protection. For an amphibian, half a hectare is actually a very large wetland. We know from studies that many frog and toad species are actually attracted to low canopy cover wetlands. What you have to keep in mind is that amphibians, the majority of their young, the eggs and the larvae, are going to try to metamorphose within the same season. So they need to develop very quickly, and their development rate is tied very closely to water temperature. So unlike fish, amphibians are actually seeking warmer water conditions, especially because they're laying their eggs very early in the year when it's still quite cold. So they're looking for any sort of jump in temperature, even a couple of degrees. And when you have low canopy cover, then you've got more sun exposure. But for most of us, if we were thinking in the context of what happens when you remove forest cover from a wetland, these would be the things that might jump out as concerns. There could be direct mortality during the actual harvesting, and then the actual loss of forest cover, and that clear cuts could potentially be a barrier to movement. And then lastly, which I was focusing on, was that the wetlands would dry too quickly, and then you'd have mortality of the young. So in 2000 actually, a study was initiated here on Vancouver Island by Macmillan Bloedel, the company here in Nanaimo at the time, that wanted to look at the effects of variable retention harvesting on biodiversity. And they were wanting to move away from clear cutting. So they wanted to look at what ways you could leave trees within cut blocks, in what sort of configuration and density. And amphibians were one of the indicator groups that was being considered at the time. And what we noticed in some of those initial work was that we noticed amphibian breeding was fairly common in ponds in cut blocks. As well, I noticed that a lot of these small wetlands were often used as the anchor points for where the company would be leaving these small retention trees, these patches of trees. But there was no biological basis for where they were putting these trees. And it was curious to know whether these trees were serving as any sort of a buffer for these wetlands. So the primary objective of the study was to experimentally determine the effects of forest harvesting on the duration of suitable hydrological breeding conditions on an annual basis and across years. and the use of these wetlands before and after harvesting. Were these wetlands going to continue to be used after breeding, or were they potentially going to be new usage for breeding? And then the secondary objective was to identify potential indicator variables that may reflect suitable breeding habitat conditions. The study sites are located in the Nanaimo River area, just southwest of the city of Nanaimo. The 3 sites are Bear Creek, Dunsmuir, and Reinhardt. They're all in the XM Beck variant. They vary from 8.5 to 22 hectares in size. Reinhardt and Dunsmuir were old growth stands in the pre-harvest conditions. Bear Creek had some fire history, so it was only 85 to 88 years old, but had never been harvested. They were all over 300 meters in elevation and had over 20 small wetlands within each of the blocks. And they were scheduled to be harvested. This is the surveying schedule and the harvesting schedule. So in 2004, I was able to collect some pre-harvest data at all 3 sites. And then unfortunately, there was a miscommunication with the company, and the Dunsmuir site was harvested, and I was only able to get 1 year pre-harvest data at that site, but I was able to get a 2nd year at Reinhardt and Bear Creek. And then in 2006 and 2007, I collected post-harvest data. And then, as I've mentioned, I was able to go back this year, 15 and 16 years later, to look at post-harvest results. Amphibians were surveyed using 2 main techniques, visual surveys and a round of funnel trapping. And then I collected habitat data as well, and I'll go into detail on how that was collected. The visual surveys for amphibians were conducted every 2 weeks from spring until the, late summer. And then the 1 round of funnel trapping happened at some point at the end of May and early June. Every 2 weeks when I was at each pond, I would measure the water depth at a designated location where we had put a stake at the deepest location. And I would also measure the water temperature at that location. In 2020, I had access to data loggers, and I was able to put one at each site, and I used a little foamy float and a string and tied the data logger to that float so that it would move up and down with any change in water level. And at some point in early June, I would record a general wetland description, making visual estimates of canopy cover, percent cover of vegetation of different layers, as well as open water, bare ground, and downed wood. So one thing to note here is I had these interesting little, a sponge noodle that I had in the shed, and I cut that up to make this little foamy for the data loggers. And it was really frustrating. We kept coming to some of the sites and something kept chewing on the foamies and pulling them off of the stakes, and we'd find the data loggers sitting on the bottom of the pond. Luckily, we didn't lose any of the data loggers. We weren't sure what animal it was, so we decided to put out a couple of wildlife cameras at some of these sites where we were getting constantly harassed by something. And so we got some shots of some of the organisms that are animals that are going into these small wetlands. We had raccoon, we had mink. And then on one of the days, the animal was nice enough to show itself. We had a black bear come into one of the sites, and we watched through the progression of photos as it walked off of the logs straight toward the stake there in the pond, and then was able to show us exactly as he had pulled the foamy off of the stake and was chewing on it. I imagine it's kind of like, maybe like chewing gum for a black bear. It's nice and spongy. So the results of our study in terms of hydroperiod at 2 of the 3 sites, what we found was that the wetlands were deeper. The average depth was deeper post-harvest. So I'm just going to walk you through this graph here. The bars represent the average maximum water depth between June and September, and the dark bars are Bear Creek, the medium bars are Dunsmuir, and then the lightest bars are Reinhardt. And that's for each of the years of the study. And then the bar for each of those sites that has a black outline, that shows the first year after harvesting. So in 2004, we have all of the pre-harvest data for all 3 sites. In 2005, Bear Creek and Reinhardt are still pre-harvest data. We see a significant increase in water levels at Dunsmuir, which is the first year post-harvest. And then in 2006, 2007, and 2020, this is all post-harvest data for all 3 sites. So for Bear Creek, we see an increase in average water levels initially after harvest, 2006 and 2007. By 2020, it looks like it's coming back to pre-harvest levels. At Dunsmuir, we see a significant increase in water levels, the average depth the first year after harvesting, and then it's remaining above the pre-harvest 2004 levels. At Reinhardt, we don't see that same sort of trend. There's a potential increase in water levels in some of the years initially after harvest. What it's interesting is that the pattern of average water depths from year to year is not following either of the precipitation, total precipitation levels for those years, which is the total precipitation is the dark line on the top, and the blue line on the bottom is the precipitation from June to September. So I still need to do the actual data analysis on this, but it's suggesting that it's not following precipitation levels. It's more likely related to harvesting. And this makes sense if you understand how things work hydrologically within a clear cut. If you remove the trees are what was removing a lot of the water from the ground. So you're going to have a lot of the water left in the ground once the trees are gone.
Hi, Elke. Sorry to interrupt, but we have a question. What brand of data logger did you use?
They're the Hobo data loggers.
Okay, thank you.
And the next information around Hydroperiod was not just that they stayed, that they were deeper, but they also stayed wet longer after harvesting. But by 2020, we're starting to see a shift back to pre-harvest levels potentially. So again, this is just Bear Creek and then each of the steady years. And if we look at the color coding, we're in the blue range, we're in early spring to early summer, or yeah. And then as it gets into the warmer colors, we're moving from summer into September. And what we see is that the percent of wetlands that dried in any given period, in those 2-week periods, we're seeing a shift once we go into the post-harvest years. So that's 2006, 2007, 720. We're seeing that they're drying into September, the majority of the wetlands, whereas in the pre-harvest years, especially in 2004, they were drying by July. And then in 2005 pre-harvest year, they were drying in August. So we're seeing that the wetlands are staying wet longer. We see this also with Reinhardt, where we're seeing the shift into September for 2006, 2007. By 2020, we're shifting back towards August. And we also see that in Dunsmuir. Again, we only had 1 year pre-harvest data there where we're seeing a lot of the blues. And by the time we get into 2006, 2007, we're seeing a lot more into the warmer colors there. So we're shifting farther into the season, longer hydro periods. So what does this mean for amphibians? How did they respond to forest harvesting? We had 4 species that we saw at the sites. We had Pacific tree frogs, long-toed salamanders, red-legged frogs, and rough-skinned newts. The rough-skinned newts, the breeding is a little bit different for these guys. There's some detection issues because they lay these small single eggs on vegetation. So we couldn't survey for eggs. The larvae are very small, difficult to detect, and they don't have very distinct breeding season. They seem to lay at odd times. So I've excluded them from the data analysis at this point. So in terms of amphibians, only 2 of the 68 wetlands, or 3% of the wetlands, had fewer species breeding in the pond post-harvest compared to pre-harvest. So we had about a 60% occupancy rate for breeding pre-harvest, and then it moved to 79% post-harvest. The 2 sites that we had decreased species occupancy were at the Dunsmuir site. Red-legged frogs were lost at one of the wetlands 2 years after harvesting, and tree frogs were lost at one site in 2020. I'm not surprised that we're starting to see a potential decrease in frog use by 2020 because those cut blocks are starting to have quite an increase in vegetation, and it takes this, I think, potentially the smallest amount of shading on a pond to make it less attractive for tree frogs.
Okay.
Yes.
Sorry to interrupt. After the logging, was the area reforested, and with what was it reforested with post-harvest?
A good question. Yes, it was planted and I think they're all Douglas fir. I haven't even really paid that much close attention to it, but I think mostly Douglas fir. So what we have here on the green bars are the pre-harvest, the percent of wetlands that we're seeing, and then the orange bars are breeding post-harvest. So you can see at all 3 sites, we've got higher occupancy for breeding. And when we break it down by species, the orange bars are the long-toed salamanders, the darker bar is pre-harvest, the lighter bar is post-harvest. We see that it's applying for all of the species. The Pacific tree frog are the green bars, and the reddish bars are red-legged frogs. What's interesting is at the Bear Creek site, we actually had a lot of adults at that site pre-harvest. We never had any breeding. And then as soon as we had harvesting, we actually had red-legged frogs start using some of the ponds for breeding. So what do we think we know from the study so far? The wetlands did not dry faster post-harvest, and in fact the wetlands were deeper and they stayed wet longer after harvesting, especially initially. I think by 2020 we might be starting to see things go back to what they were like in pre-harvest years. And the amphibians did not stop using these wetlands for breeding. In fact, their use increased, and especially for the frogs, they were most likely attracted to the low canopy cover conditions. Here's what we don't know. We don't know what the reproductive success means for the overall population. We do know that they metamorphose successfully at these ponds. There was a couple of ponds in some years and dry years when we had some larval death. But in general, we see these amphibians make it right through to metamorphosis. But what is the success of these little metamorphs in these clear cuts when they're coming out right in midsummer at the hottest, driest time of the year? It takes very little vegetative cover when you're only a couple of centimeters big to provide probably quite a bit of cover and shade and moderate temperatures. But nobody has looked at this. It would be quite a big study to try and figure out survival rate, but that's really where we need to get to. And what's important is we don't know what the long-term effects of harvesting are in the face of climate change. So we know that these wetlands are probably going to be starting to change, if they haven't already, with increasing temperatures and changes to our precipitation levels. So continued monitoring will be helpful to try and get at that. I'm hoping with my data analysis, I'll be able to tease out or separate out what might be climate change and what might be forestry, but my analyses are ongoing. So I'd like to move on to the second study, which I've called Roads and Toads. This was a large collaborative study. There were a number of research biologists here on Vancouver Island that were involved, and we had a large number of project supporters and volunteers and funders over the number of years for this project. So how do roads affect amphibians, like, for example, western toads? We know that aquatic breeding amphibians need to move from their aquatic breeding sites in upland terrestrial habitats on an annual basis, and that there are multiple migrations a year. We also know that amphibians will and do cross roads. They are not a barrier to movement. I was just driving on the highway here on Vancouver Island recently, coming back from Campbell River late at night on a very rainy fall night, which is when they're doing their fall migration. And I saw lots of amphibians on the road. And I think at one point I even saw a toad on the highway. So this is a large 4-lane divided highway, and they're making an attempt to get across the highway. So they will cross very large roads. And in fact, some amphibians, like toads, may actually be attracted to roads. So you've got a warm surface. These guys, like western toads, are active at night, and they'll come out onto the road just after sunset. They'll flatten their bellies out onto the road, and they'll bask in that way. They'll try and warm up a little bit. These are ectothermic animals, and they need to warm up their body temperature in order to digest food. So just as they're going out to forage for the night, they're warming up their body so that they can move and they can digest their food. And like us, and like most other wildlife, they're going to try and take the easiest path for movement. So we saw with some of our work that they get onto roads, and we think that they just will walk hundreds of meters to kilometers or crawl along the road. It's the same as us. If we're out in the bush and we've got an option to jump onto a wildlife trail, we're going to take it. It's just a lot easier and more efficient. Roads also provide a very unique habitat type. They have different type of vegetation or cover along the roadside. You have road banks, which are generally a little bit looser soil, and you can get a very nice south-facing slope. And then you've got ditches where you could potentially have pooled water that could be used for breeding, or at the very least, they're moist and they could provide a nice moist travel corridor for an amphibian. We focused on western toads for a number of reasons. They are a listed species federally. We've seen some population declines in the US, and we suspect there's also some along the south coast of British Columbia. This is a very Pacific Northwest species, and they're an example of what's considered a fairly widespread common species that is vulnerable to decline, and we can have very drastic declines happen in a short period, even in pristine areas. So in the Rockies in the United States, we saw declines in large parks, so there was no obvious stressor that we knew of that was happening at that area. Since that initial work began where we noticed the declines, we know that there's a fungal disease that western toads are susceptible to. They're also particularly vulnerable to roads and urban development. Toads can travel far and wide compared to a lot of other amphibian species. They can move on kilometers on an annual basis. As I've mentioned, adult toads are attracted to roads. The good thing is that adults tend to move at night, and that could be one thing that potentially protects some adult toads. Maybe the traffic is a little bit lower in the evening, we're hoping, so that they're not getting hit as often as they would if they were active during the day. The other characteristic of toads is that the young, the tadpoles, and then the metamorphs, when they come out of the wetland, all tend to hang out together. They're all at the same developmental stage. They move onto land en masse, and then they'll disperse en masse, following each other through the landscape. So if the direction that they're moving happens to have a trail or road or something in that pathway, you could have fairly high mortality rates by the thousands. And these guys do move during the day. So when there are roads in the area, they can have suffer from significant mortality. So we started this study in 2011 and 2012 because we were concerned about toads being killed around a lake, a breeding site in the Duncan area. And the Ministry of Transportation Infrastructure supported some work to look at road mortality. So we surveyed roads around this breeding site in spring and fall in 2011 and 2012, and we were trying to locate a potential crossing hotspot where we could put in an underpass. And what we found was that the hotspots vary by species and by season. So the left graph at the top are the results of the fall surveys, and the graph, the image on the bottom, are the spring surveys. So what you can see from this breeding site is that it's almost completely surrounded by roads. And depending on whether you're looking at the fall or spring, the warmer colors, so the red color and yellow colors, are where we had the highest numbers on the road. We can see that the positioning of that hotspot shifts a little bit. In the fall, it tends to be on the river bottom road area. And then in the spring, it shifts down a little bit and starts to extend onto the Barnjum Road area down on the bottom here. And then if we look at the two species at risk, western toads and red-legged frogs, the western toads are the red dots, red-legged frogs are the blue dots. You can see it's very widely dispersed. We have a bit of a hotspot for western toads along this river bottom road area, but for red-legged frogs, it looks like it's actually more along the Barnjum Road area in a number of different spots. So this makes it a little bit challenging when you're trying to figure out how to mitigate the effects of roads. MOT was willing to install a small underpass. They were ready to do it in 2013 after we finished our work, but we had some engineering constraints in terms of where we could put our underpass. So after all of this work, even though we identified a location, it turned out that that particular location along the road was not ideal. There were some structural issues with the road there, and we would have to move it farther south than where we had located the hotspot. We decided at that point to delay installation of the underpass for two main reasons. Amphibians don't want to go through underpasses. They don't want to purposely go into a dark, concrete, cold tunnel. So you basically have to force them through, and this is how we use directive fencing to lead them towards these underpasses and force them to go through it. They require fairly extensive amount of fencing and maintenance needs and a commitment to taking care of those fences. So we have problems because once you move off of the road surface, you're moving into private land. So you need to have some sort of commitment by private landowners to allow these fencing and to take care of it. So that can be quite complicated. And we knew that there was a proposed housing development that was going to go in just west of the breeding site. We didn't want to lead these amphibians straight into a proposed housing development. And we again didn't know who was going to be owning the land and where these fences could go. So we decided to wait, but I'll mention later on a bit more about this work. Sorry, I just need a bit of water. So in 2015 and 2017, I teamed up again with the province, with the Ministry of Forest Lands and Natural Resource Operations, and we decided to put some effort into trying to understand what these toads are doing in the terrestrial environment. We decided that we wanted to get a handle on hibernation. As I've mentioned, toads live on land for most of the year, 10 to 11 months. We know almost nothing about what habitats they're using or what they require on land or what they need to survive the winter. And there's a suggestion that hibernation sites could be as important, if not more, to the population than aquatic breeding sites. So there was a study conducted on toad hibernation in Alberta. And what they found was that the hibernation sites were at least 1 kilometer away from the breeding sites. And they also found that over 65% of them were communal, so they had multiple toads in them. So toads are not social animals, and 1 kilometer is fairly far away from a breeding site, when the first thing you're going to do when you come out of hibernation is go and breed. You don't want that distance to be too far. You haven't eaten all winter long. So for it to be that distance away and then to be communal suggested that possibly hibernation sites were limited within the landscape. So how do you study toad hibernation? First, you need to find the toads, and then you need to fit them with a belt that can hold a transmitter. We had 2 main methods of capture. We used a large network of volunteers within the Duncan area, and we also conducted road surveys at night. And once we had access to a toad, we would record the weight and length of the toad and then design a special belt that would fit around the waist of the toad. You can see on the bottom there, the 2 images. It was a little bit of neonatal tubing with some flexible sort of jewelry cord that we put into the middle of it. And then the transmitter is fitted with a hole or a tube through it so that we can feed that elastic cord through. So as the toad's moving through the landscape, if the belt ever got caught up on any kind of vegetation or anything, the elastic cord inside would stretch and the animal would be able to just pull its leg through. So we actually did have a lot of belts that ended up getting just dropped off of toads. So you never want to stress the animal. So we made sure that the weight of this transmitter and belt combination was less than 5% of the body weight. And again, we had that stretchy cord so that they would never get hung up or caught on anything. So what's happening with the transmitters, it's sending out a pulse, and then we were using a receiver to pick up that pulse. And the receiver has a limited distance that it can detect. So we relocate the toad every 3 to 4 days during the fall so that we don't lose the animal. And we would record the little microhabitats that it was in and where it was moving. And then once the animal had hunkered down for hibernation, hibernation for the winter, then we only had to go out once a week and just make sure that the animal was still there. It's interesting because you'd think it'd be fairly straightforward to do this work, but it can be quite challenging because when you're working in an urban environment, a rural landscape, we were having to access all of this private land. And so, of course, the toads were moving. Wherever the toads wanted to move, they were completely unaware of property boundaries. And so we had to contact people constantly and get permission to access their land, and which we greatly appreciated. And we had to deal with a lot of signal bounce because you've got buildings and trees and a lot of metal and mineral soils. All these things can cause a lot of bounce. So it made the work quite challenging, but it was really interesting. So what did we learn about toad hibernation? We captured 61 toads over the 3 years, and we were able to confirm 28 hibernation sites. So that big difference in number is just an example of some of the toads that, a lot of the toads that slipped out of their belts. And there were only a few toads that we had to remove belts, just if we started to notice any sort of skin irritation. There were 4 main things that we were interested in learning. One was, when were they hibernating? Where were they hibernating? Were any of the hibernacula communal? And then how far did they move between hibernation and breeding sites? In terms of when toads hibernate, on average, the toads were hibernating for 81 days, and that ranged from 40 to 100 and almost 120 days. So it was on average about 2 3/4 months. Most started to hibernate in November, and then they emerged in January. But the emergence dates were actually quite variable from year to year. So in the first year of the study, the majority of individuals emerged in February. In the second year, the majority emerged in January. That was a very mild year. And then the last year of the study, most of them emerged in March, which was a very cold year. So you can see how that emergence can then affect the timing of breeding as well by a month or 2. In terms of where the toads were hibernating, one of the really interesting things for me was that although we watched toads travel through and often linger for days within what I'm calling built environments, no toads actually chose to hibernate under or near any sort of buildings or any sort of human structures. The exception being one toad that chose hibernation spot in a road edge. 70% of the toads hibernated in or close to areas with relatively open habitat. And that would make sense. They're more likely seeking out just sort of the perfect sort of thermal conditions. So maybe some area that provides some sun exposure, but is not too exposed. So on in the table here on the bottom, only 30% of the toads hibernated in forest, and then 43% were along habitat edges, and 27% were in a maturing clear cut. All of the toads hibernated underground. Most of them were in association with, or if not all, with some sort of woody structure. So some of them hibernated under large logs. A lot of them hibernated in stumps. And these are old, rotted out stumps. And what I found with a lot of them was that they're basically rotting from the inside out. And what you tend to have then is all of these old root channels that basically act like straws that lead them straight down underground. We don't have any sort of burrowing mammal here on Vancouver Island like we have on the mainland. There's no ground prairie dogs or anything like that, moles or anything that can dig holes down underground. And so I think that these rotted out stumps are very important for them to get access underground and away from freezing conditions. There were a couple of toads that hibernated in some sort of a hill or a mineral bank. But even in those situations, we saw evidence of some sort of wood buried in the bank that they were associating with. These hibernation sites, for the most part, were quite difficult to identify. They weren't very obvious at all. We would have to really dig around. We would often see just a big shrub of salal or something, and then once we got in and actually dug around, then we were able to see that there was an old rotted out stump in there. So that's not very helpful from a management perspective. In terms of whether hibernacula were communal, we set up wildlife cameras at a number of our hibernacula, and we did see multiple toads come out of a few of our hibernacula, and then one of our hibernacula was actually used across study years. So there is some evidence, but it doesn't appear to be as strong as it was in the Alberta study. And I'm not sure if you can see there, but this is one of our toads coming out of his hibernacula. That was the first one that I found, and I was pretty excited. What happens is, in order to use these cameras, you have to set them to take a picture every minute. And a cold-blooded animal can't trigger the camera, or these particular types of wildlife cameras. And so you're spending hours and hours just going through, just clicking and clicking through thousands of pictures, looking for something different on the picture from one picture to the next. And this guy, when he first emerged, I could see movement in the hole, and he spent about 30 minutes just sort of hanging around the entrance to the hole, and then finally just came up and scooted off to the left. So it was very exciting. So the other question we were interested in was, how far do toads move? What are the distances between hibernacula and breeding sites? So the average distance was almost 500 meters between hibernacula and breeding sites. And the females were over 700 meters away from the breeding site. Males were much closer, about half the distance at 342. And this makes sense because the males tend to show up at the breeding site first. They can be at a ratio of 6:1 males to females, so it's very high competition for females. So I imagine they want to hibernate as close as they can, get there as soon as they can, and intercept as many females as they can. What I want to point out here, though, is that we have 4 what I'm going to call non-breeders. They hibernated at variable distances away from the breeding site. And we would track the toads when they first came out of hibernation and just initially track them towards the breeding site so that we were confirming that, yes, they were going to a specific water body and that they were going to breed. And these 4 didn't move at all in the spring. We know that females will skip years for breeding. Breeding is very energetically expensive for a toad. And so we suspect that these were females that weren't breeding in any given year and a female that was potentially not reproductively mature yet. The average distance between where we caught a toad in the fall and its hibernation site was 500 meters, but that ranged up to 2 kilometers, almost 2 kilometers. And from the initial capture point in the fall to the breeding site the following spring was over 1 kilometer, and for one toad up to almost 3 kilometers away. And most followed very directional movements in the fall towards the breeding site for where they were going to hibernate. And this graph shows it here. So with each of these lines represents a toad, and the star represents the capture point, and then the sun shape is where they hibernated. So what you see for every one of these toads, regardless of where they were captured around the breeding site, they're all heading in a very specific, almost very straight line path towards the breeding site in terms of where they wanted to hibernate. So this is very complicated from a management perspective because they're not following streams or wetlands. So any sort of traditional buffer or a corridor that we might set aside in a landscape from a management perspective, they're just going to move in as straight line of direction as possible. So that makes it very difficult to figure out how to protect these individuals, and it really points out how we need to consider the total landscape context. I want to highlight one toad in particular. Most of our toads had to cross numerous roads in the fall to get to their hibernation site and or in the spring in order to reach the breeding site. So T41, this guy moved 1,500 meters in the fall between September 22nd to November 7th. So we caught him over here on the bottom right, and here is the breeding site over here. So our first relocation hadn't moved very far. Second relocation, he made his first road crossing. The third relocation, fourth relocation, made another road crossing, and then fifth relocation, crossed another road before he hibernated. And this was fairly common for a lot of the species in this landscape. So we mentioned the maximum distance between hibernacula and breeding sites. So the maximum distance for the individuals that bred the following year was 1,600 meters. And then the maximum distance, if we include all of these non-breeders, is close to 3 kilometers. So I want to put this into sort of a perspective from a management perspective. So if we're just thinking about the breeders in any given year, we need to be considering that 1,600 meter boundary. So I've put on 3 of the political boundaries here, and we can see that we're starting to go crossover from one political boundary into the next. If we want to consider all of the toads in the population, so even the ones that aren't breeding in any given year, we need to expand that circle to at least 3 kilometers. And now what we see is we're going into 3 different political boundaries. So let's go through some of the needs and the threats for Western toads if we want to protect the population in this area. So we know that they need to be able to safely move between their breeding sites and their hibernation sites. At a bare minimum, we know that we need to protect that. We know that they move a lot farther than that. So the biggest threat there is road density and traffic levels. So I want to point out from this example here, where our toads were captured. Whoops. You can see that in this box, for whatever reason, we caught a lot of toads along these roads here. So it's a high density of toads captured in those areas. And then these are the hibernation sites. And we see that a lot of them occur within that same box. What's really frustrating as an amphibian biologist is to know when we were on the ground that these are all of the areas that are slated for development. They have for sale signs, they have pins going in to designate out the property boundaries, and they all occur right within that box. So if all of these developments go through, I'm not sure that this toad population will be able to survive. Also, as I mentioned, these toads have to cross these 3 roads here where the lake itself is almost completely surrounded by roads. There's also a proposal to extend this Barnjum Road through to this road over here. And that just increases the number of roads that these toads have to cross, increases the traffic as well. So the second need for this toad population is they need high quality breeding sites such as Wake Lake. So anything that is an impact to an aquatic breeding site is a potential threat. More specifically, the threats are that we don't know the location of all of the breeding sites. So that makes it very difficult to try to protect them. And we have a loss of riparian cover around Wake Lake. We've had a bit of development there. We know that there's always interest with these wetlands to provide some sort of human access, for example, trails or putting a dock in or something like that. And that's at this site, we're really hoping that that doesn't happen. It's quite dense shrubs all around the wetland, except for adjacent to one private property. And that keeps people out, and that's a really good thing for these toads. As soon as we provide human access, it pretty much leads straight to habitat degradation. It could be an introduction of disease or non-native species. People like to throw fish into any water body that they've got access to. And we know that there's been a real lack of consultation or communication with us when there's been road work around the area. We've had beavers move into into the Wake Lake site, and they've gone in at various times to try and control that. And at one point they took the dam out right during the egg laying season. So the water levels dropped drastically. So we don't know what the mortality rates were in that given year. They've also conducted road work as a result of the flooding. And they did that during one of the critical toad movement periods. So what they ended up doing was directing the traffic off of the main road around Wake Lake. And so it had a real increase in traffic that year. So it was probably very significant toad mortality on the road that year. We also have problems with non-native and invasive species. This lake has bullfrogs and green frogs, non-native amphibians, and subsidized predators are a problem. When we do shoreline surveys during the breeding season, we find a number of dead adult toads every year. That seems to be normal for a number of different sites, but at some point it's going to have potentially some significant impacts. We set out some wildlife cameras and we determined that there were raccoon moving through. At other sites, it can have problems with ravens and crows. Animals that are smart enough to know how to get around the toxic skin of a toad. And these animals they're called subsidized predators because they tend to do very well around humans, and their populations can get quite large. The third need for toads is that they need high quality hibernation sites. So anything that impacts those sites is going to be problematic. More specifically, any loss of habitat complexity above and below ground across the landscape is going to have an impact on toads. They need to get down underground away from freezing conditions. So our practices like agriculture and in some areas of development that compact the soil is going to lead to problems for toad hibernation. And then the loss of downed wood and stumps is going to be problematic. And we know that the only way to have large downed wood and stumps is if you leave large trees. So the conversion of natural vegetative cover to developed areas is going to lead to a decrease in potential hibernation sites for toads. But I would argue that development is really the biggest concern. It leads to permanent land conversion. As we saw from the forestry work, a lot of the impacts from forestry are temporary for amphibians, and that does tend to maintain a lot of the microsites. It leaves a lot of wood and stumps on the ground, and it doesn't result in as much for soil compaction. So one of the other things that toads need is collaboration, cooperation, compromise, and communication. We saw the location of where all of these toads were within the landscape across all of these different political boundaries, how they're moving straight through the landscape. They're not following any sort of convenient corridors that we could leave buffers on. So we really need to have a lot of support from all levels of government, from private landowners, and from land managers. This collaboration comes in a number of different areas. With roads, we need to be considering the number of roads, the amount of traffic that's on those roads, installing underpasses, considering seasonal closures where we can, where roads are right adjacent to breeding sites. We need to protect wetlands, and we need to have non-native species management where possible. We need to protect forest cover, provide education and incentives to keep trees and stumps and logs on the landscape. We want to retain as much large stumps and downwood as possible, protect large trees. Again, education and incentives can be really good for that for private landowners. I was able to give my toad talk to the CBRD, the Cowichan Valley Regional District staff, to planners and engineers, to people who don't often know anything about wildlife. And I wanted to just give them a landscape perspective of one organism's experience within the CVRD. And they just happened to be working on their official community plan, reworking it. And I was really happy to see that after I gave that talk, they made some changes that were directly related to our Western toad work. They, under the forest policies, that lot that was adjacent to Wake Lake that had a proposed housing development, they wanted it to remain as forestry. They didn't want it to be rezoned for housing. That means that we now are considering, we're working again with MOT and where to put this underpass. It looks like we're going to finally be able to put this underpass in and put the fencing in so that we can help the amphibians get under safely across that road. In their parks policies, they are going to try to acquire additional lands around Wake Lake and then partner with others to address some of the road issues through signage and temporary road closures, etc. And my biggest hope is that this last policy will go through around rural residential. They don't support any further subdivision rural residential lands within 2 kilometers of Wake Lake. Unfortunately, my biggest proponent at the CVRD has retired, and I'm having to rework my relationships with them and the people that I'm working with to try and get this information through and into the OCP. It's still being worked on, and some of the things have changed, unfortunately, but there's hope that we'll still be able to get some of this stuff through. If you've absolutely fallen in love with toads through this talk, I've got some toad-friendly things that you can do, and this is information that we hope to get out to all the landowners in that area. If you live anywhere near a wetland, be aware that anytime that you're driving there at night during a migration period, so in the fall, after you've had that really hot, dry summer, and those first big fall rains are usually at the very beginning of September, or by mid-September. Those very first real soaking rains are the ones that are going to trigger migration. So if you can avoid driving at night on those rainy nights in the fall, anywhere near wetlands, you're going to be saving a lot of amphibians. If you have wetlands in the area and you have access to them, if you can try and find out whether there are toads breeding in those ponds, it would be information that the province would be greatly appreciative of. You can enter that data into the Frog Watch or the SPY databases. When you're doing landscaping and yard work, if you're near a toad site, you'd want to be very conscious of any type of mowing during the dispersal period, because there can be a lot of little tiny, 1 centimeter toadlets all through the landscape. And anytime you're doing any kind of renovation work where you're moving lumber or wood piles, they could be in that. I was just working with somebody where there were a large number of cedar roofing material covered in moss that was on the ground. It had been piled there for almost 2 years, and so we were finally clearing it up. And we came across 3 different species of salamander within all that debris in the yard, and this was right in the middle of Nanaimo. So there are a lot of amphibians that will take advantage of a lot of these debris piles and things that build up in our yards. If you can avoid removing stumps when you're doing landscaping work, if you've had to cut a tree down, it would be really great if you can leave it. If a stump has to be moved, it'd be really good to not remove it during the winter hibernation period. We had one landowner in the Duncan area tell us that when he removed a stump in the fall, there were something like almost 12 toads in that stump. And if you remove them, disturb them in the winter when it's cold, we're not sure that they would be able to make it to another hibernacula at that time. So that's a really important one. And then providing cover for migrating and overwintering amphibians. So retaining as much tree cover as you can and shrub cover, logs, stumps, and creating habitat through rock and wood piles is beneficial for amphibians as well. I just want to acknowledge that there were a really big number of volunteers that helped us catch toads. And I was really surprised and really appreciative of the number of people that gave us access to their private land in order to do all this toad tracking. I think that was very, very generous. I really appreciate it. In summary, aquatic breeding amphibians are a group that really demonstrates the need to consider landscape context in relation to wetland conservation, because they're migrating between aquatic sites and upland habitats. They're utilizing these upland habitats for the majority of the year, and most of our amphibians are actually hibernating in upland areas. And they seem to follow very specific migration pathways that don't always follow the most convenient sort of corridors or pathways that we might be able to protect through riparian area conservation. And although amphibians are very adaptable and they can utilize a variety of upland habitats like clearcuts and agricultural lands and rural areas, urban development and roads pose a really probably the most significant threat to their survival. Where we increase urban density, we increase road density and traffic volumes. We need to protect natural wetlands and upland forest cover. There was a study in King County in Washington, and they found that the relative abundance and species richness of wetlands within that landscape was closely related to the proximity of forest cover within a kilometer of a wetland. So when we're thinking about wetlands, we really need to be thinking about forest cover as well. So we need to think about landscape context when we're restoring and building wetlands. And if you have any questions, I'd be happy to take them. We have a blog from our toad work, and there's some great videos there if you want to watch. Thank you.
Great, thank you so much, Elke. That was fantastic. I know that we have a couple questions in the queue, so I'll let Molly ask them on our participants' behalf.
So the first question we had was, how can we address the lack of smaller wetlands protections?
Sorry, I'm just mucking around with my computer here, trying to figure out where I am. There we go. Oops. Why won't you come up? I'm trying to figure out how to stop sharing my screen here. There we go. Am I still sharing or no?
No, you're good.
Okay, good. Sorry, what was that question again?
How can we address the lack of smaller wetland protections?
That's a really good question. Probably Neil can help address that almost better than I can. It's a big focus for the BC Wildlife Federation. I know that one of the things that I found particularly interesting in my reading was how there was a group in Connecticut, and what they recognized was that if a wetland wasn't on a map, it didn't get protected. And so what they did was they had volunteers go out anytime they were hiking or anywhere within the landscape. And as soon as they came across any sort of puddle, wetland, get a GPS coordinate and then send it to somebody in government, in planning, to make sure that that wetland ends up on a map. And that's a really big problem with a lot of these small wetlands. So when I was doing work in the very, very early stages of that forestry project, we surveyed hundreds of wetlands up in the North Island and through the central part of the island. And we then got and we were walking transects and marking every single wetland that we came across. And we took that information to the forestry company. We had the person who analyzed the orthoimagery. We had them reanalyze the orthoimagery. And what we found was that 65% of the wetlands that we found by walking on the ground were not visually visible looking at the orthoimagery. So the only way to find these small wetlands is by walking on the ground. So that's the only thing that I can think of, other than just trying to get into the ear of politicians at the importance of these small wetlands. But getting them mapped is really critical. And then I think we need incentives for landowners, basically, to protect these small wetlands. Otherwise, they're only ever going to get protected in parks and things, and we need them to be protected across the whole landscape.
Okay, lovely. Next question was, what water quality variables are important to monitor for amphibians and why?
That's a good question. A lot of the habitat stuff that I've seen, the research, it often doesn't come out very strong. And so I think we often aren't measuring the right things. It's very hard for us to figure out exactly what amphibians are queuing into. So the short answer to that is that I wouldn't focus too much on water quality. It seems to be more about structural things. So the types of plants that are in the wetland, the types of graminoids, so the grasses and the sedges and the rushes. And it's actually more about just their thickness of their diameter. You don't really need to even focus on the species. So it's about the vegetation, it's the amount of open water habitat that you have within a wetland, trying to keep as much open water as possible, but still providing vegetation for egg laying. And then again, it's about that terrestrial habitat cover. So I wouldn't put too much emphasis on water quality. They tend to survive in a really wide range of water quality conditions.
Okay, lovely. Linda asked, can you say anything about whether this tendency to not follow streams or buffers is just with toads or with other amphibians as well?
That's a good question. I really can't say. Toads and newts have more unique skin compared to other amphibian species. So they can tolerate drier conditions and they are moving around a lot farther. I think something like red-legged frogs, some of the larger frog species are also probably able to move more directly through the landscape. The ones that might be more sensitive and might stick closer to streams and things might be the salamanders. So until we do more radiotometry work on species, it's really hard to know what exactly they're following. I think that energetically, they're going to try and follow the most direct path that they can.
Okay, great, thank you. Do you think the slash left over from the logging provided natural habitat for the amphibians?
Yeah, I think it's really important, especially in those first couple of years after harvesting when you don't have a lot of vegetation coming up. I think that for sure the slash would be really important. The stumps that are left in the ground as well, and the soil compaction would be really important. Yeah, because I know in some cases they will clear a lot of the slash off and create these big piles and then burn them. And I think leaving as much on the ground as possible would be good, but we do have issues with fire, so there needs to be a balance in there somewhere.
Okay, fantastic. Kiara asks, the timing for reduced mowing, June to August, is when people usually want to be mowing. Is there a time of day that would be best if people are going to mow anyways? Yeah,
I haven't thought of it in that way before. I actually probably mow the least at that time of year because that's when my lawn tends to die. So if you're watering your lawn, then you're going to have to mow. So there's one solution there would be to maybe let your lawn go brown if you can. I know there are some places that are trying to really deter people from watering their lawns, and they have a brownest lawn competition in some places, which is a great idea. But if you really need to mow, what we found with our metamorphs around the Duncan site was that they tend to be crepuscular, so they're moving mostly at dawn and dusk. So if you were mowing in the middle of the day and the hottest time of the day, then they're probably just going to be hunkered down.
Awesome, thank you. Is there any info out there on the different amphibian species in our area and the average migration distances to their hibernacula?
There have been very, very few studies on hibernation. There have been 2 or 3 on toads now. To be honest with you, I can't even think of other species where they've done work, because it's only fairly recently that the transmitters have gotten small enough that we can start to fit them onto amphibians. So it's a very new area of research. There's some evidence through sort of more anecdotal stuff. So somebody who's digging around, they were doing some work around a stream and came across amphibians that were in the stream bank. So we think that amphibians will take advantage of the layered soil and the cavities around stream banks to overwinter. In my work, we put cameras out at those hibernacula. And so as I mentioned, I was going through thousands and thousands of pictures. And so I did see a lot of salamanders and other frog species coming out of those stumps as well as small mammals. So there's a lot of things using those stumps. I suspect a lot of, if not all, the amphibians are trying to use that type of environment. And then under logs as well. So, but the distance is moved, no idea. Really can't tell you, unfortunately.
Awesome, thank you. Bonnie asks, regarding case study number 1, were any herbicides sprayed post-harvest, and were contaminants in the breeding water measured?
Thanks for the reminder. I actually need to do a follow-up with the forestry company to find out what the post-harvest treatments have been over the last 15 years. I don't know if they've used any herbicides. From what I understand, that's not really a common practice anymore in forestry here. And contaminants in the water, no, nothing has been measured. One thing I did notice with some of the ponds initially after harvest, where a lot of the limbs or some of the smaller trees and things were felled right into the pond, there'd be quite a heavy algal growth in the ponds. I'm not an algae expert. I don't know what they are, but I imagine it was potentially affecting the water quality in some way. Not necessarily a great thing for amphibians. Even just from a physical perspective, it was fairly thick and probably difficult for them to swim in and around. So sorry, I don't have anything on water quality.
Okay, thank you. Jennifer says, that was amazing. Thank you so much. I have wetlands on my property in South Nanaimo. We have western toads, red-legged frogs, and Pacific tree frogs. Are there posters or pamphlets I can access to help educate my neighbors?
I would recommend going to the BC Frog Watch website. They have fact sheets for all of the different species. And links to things there. That might be one of the best places to go to first. I know that there are some different things. Someone I know in Alberta who works for the what's it called? Alberta Conservation Association, I believe, came up with a pamphlet for landowners. More so for large farms and things like that. But Yeah, sorry, it's hard to direct you to one place. I would suggest just starting to do a Google search on amphibians and land management. Trying to think of the right words for the search, but that might get you to a number of different things, but whether or not they would be specific enough to this area, I'd be happy to come up with a one-page thing for you, or just pass along some of the points that I have. Anything that's going to go out to property owners, I'd be happy to make something up. It would take very little time. So I'm sure that Alyssa can make sure that you've got access to my email address.
Awesome, thank you. And Paige just mentioned in the chat that she's seen a great pamphlet on the BC Frog Watch website, so she recommends taking a look at that.
Great, thanks.
Next question is from Sarah. She asks, in your line of work, are you often seeking out projects with other land managers, or do developers and other agencies come to you for consulting work? I'm curious about the logistics of how these types of projects get started.
Yeah, I can't speak for everyone. For myself, it's, I think I've just been really lucky. I've been in the right place at the right time. I did my graduate work at UBC on amphibians in a forestry context. And then right at that time, there was a lot of interest in amphibians, and there was a lot of interest in amphibians and forestry. So it rolled into that work, that first project. And then I've just continued to be so focused on amphibians. The work just kind of kept coming. It's been a real variety of people that I work for, and then it just sort of exponentially grows. The more work that you do, the more your name is out there, then the more work you get, and it just keeps growing. Yeah, I don't really know. And the more you can partner. I can't get funding by myself. So I have contacts with the province, people that I've worked with, and when I have an idea, I can approach them and say, do you want to team up? Now I have these contacts with forestry. I have contacts with a large number of nonprofit groups that I've worked with. So yeah, it's just having the ideas, having the contacts, and exposure.
Okay, thank you. Michael asks, how can I convince landowners of the value of ephemeral ponds, as they often are regarded as just flooded areas?
That's challenging for sure. We still have a bit of a old-fashioned pioneering attitude where wetlands don't have a lot of value. Wetlands that don't have fish in particular don't have a lot of value. And I think it's often because people just have no idea what's in those ponds and that they're even being used by anything at all. And if they are being used by amphibians and interesting invertebrates, those animals don't just seem to have much value at all. So I think the more you can just expose people, the number of times I've been at a small wetland and I'm working with a forester, even a construction person, and then we scoop up some critters out of the pond, and as soon as they see them, they just think it's the coolest thing in the world. And then I start getting emails and photographs and what's this and what's that. And now they tell me they just can't look at a wetland the same way anymore. So the more we can just get the information out there, it's just education, really. And then I think we need more support from government. We need incentives for people to not fill these wetlands in. It's so that people don't think that they're a waste.
Okay, thank you. We have a question from Paige, but I'm actually going to hold off and ask Neil that question, just because I think he would be able to answer it a little bit better. So Paige, we have not forgotten you. We're just going to put it in the parking lot again. And the last question we have is from Barbara, and she says, we have a small wetland park and work to encourage other landowners in the Okanagan to create wetlands on their land. Can we cite a benefit to the western toad to having a wetland corridor or areas in close proximity to it?
Sorry, I don't quite understand what she means by cite.
I think saying the wording's a bit I'm not sure about this, so if Barbara, if you have any clarification, that would be great. But it seems like, can we
Is it like,
cite wetlands, like a western toad, a benefit to the western toad is having like a wetland corridor or other wetlands nearby?
is site spelled with a C as in looking for references, or?
Cite with a C, yes.
Oh, okay. Okay, so, I think it's tricky for western toads. I didn't see any, in all of the movements that they did, there really wasn't any sort of riparian connection at all. Now, mind you, I was only tracking in the fall from September until March. There are other references that you can find that track them in the summer. There are a few studies in, there's one in Washington, one or two, I think, in Washington. There are a number in Montana and Colorado. So there have been a lot of people who have done western toad radiotelemetry work. So I do a Google Scholar search on western toads and habitat use, and you'll come across these studies. And that would be a better time of year to see if there are linkages to whether or not they're following these other water bodies. Plus, you're in a much drier environment. So if you look at some of these other studies that took place in drier environments, they may associate with these water bodies as they're moving around and using them, like I said, as stepping stones. So I would look for other references. Mine is probably not the best because we're on the coast, it's cooler here, and it was limited to a very specific time of year. Other species do for sure. There's some radiotelemetry work with Columbia spotted frogs, and they move from their aquatic breeding and hibernation sites, they will move to other wetlands in the summer. So they're using wetlands all the time. The spotted frogs are good for that. And I believe you have Columbia spotted frogs in that area or close to that area. I'm trying to think of the range. That would be, that's my suggestion at this point. I do know that, for example, with the red-legged frogs, when summer comes around here and it's hotter and drier, then all of a sudden we start seeing adults around the ponds, and they're just hanging out. They're trying to stay moist, and that's good foraging environment. But as soon as it's cooler and wetter, they're up in the upland environment. So I know that they do move closer to smaller ponds and wetlands when it's hotter and drier, and then they move away when it's cooler and wetter. And I would think that all of the amphibians would do that to some degree.
Okay, Barbara actually just sent a little bit more information. She said, thank you. So perhaps just the more wetlands, the better it is for toads in general.
Definitely from a breeding perspective. Yeah, and I wouldn't want to extrapolate what I know on the coast to the Okanagan. It's a very, very different environment for amphibians. So wetlands could be really, really important for them there, for sure. And I think actually in the Okanagan, you might want to focus more on spadefoots, because it's that's spadefoot territory, and they're very dependent on these small ephemeral wetlands for breeding.
Okay, and we have another question that just came in from Liam. He said, we had a western toad population disappear seemingly without cause on a large piece of land held in trust about 15 years ago. There were no land changes to the land management. Have you heard of anything similar of a population just disappearing with no clear cause?
Yeah, I'd be really interested to know where that was. That's the timing of that, and the description of that sounds exactly like what we were seeing with western toads in relation to the chytrid fungus. So we had a population in the Souk area that was being studied by UVic on a regular basis, and all of a sudden that population just disappeared. It would depend on, when we go back to that metapopulation information, if that was what I'm going to call a source pond, one of those consistent ponds where you had breeding all the time, and then it all of a sudden disappeared, that would be very alarming. If you noticed breeding one year and then you just didn't notice breeding the next year, that can also be very common of western toads. They will often move into a new breeding site and use it for maybe a year or two and then not use it again. So you need to separate out whether or not that was a source pond or just one of those sort of opportunistic sites. So I would need to know that information too, to have a good idea of what might have been going on there. But if it was one of those source ponds and it just quickly disappeared, that around 15 years ago, that is really in line with that chytrid fungus outbreak.
Okay, fantastic. I think that's all the time we have for questions now. So we will let you go. If you have time, we'd love to have you stick around and watch Neil's presentation. But thank you again, and big thank you from all of the participants who have been saying thank you and you haven't been able to see. But we really appreciate your presentation. Thank you.
Great. Thanks very much. Thanks, guys. I will stick around. I'll listen to Neil's talk.
Fantastic.
Good morning, everybody. And Elke, I just read Paige's question and definitely would like your thoughts on it as well. It's one of the ones I struggle with, but I guess Molly, we'll put that till the end of the workshop. Is that what you're thinking?
If Elke is planning on staying and she doesn't mind giving some input, I think that'd be a great question for both of you guys.
Why don't we just ask it now before Neil starts his presentation?
That
We can, yeah.
And then they can both answer.
All right, so the question is from Paige. If a municipality is allowing, and then in brackets, turning a blind eye to developers and homeowners on private land who are destroying these small unmapped wetlands, what course of action would you recommend for a citizen such as a neighbor or a conservation organization?
That's a tough one, especially when it's your neighbor. Yeah. I think for myself, I'm not really good at knowing exactly what the rules are from one place to the next. So I would probably get as informed as I can on what the actual policies, legislation, etc. are around wetlands, from the province down to your local municipality. And then I would talk to someone in the planning department and find out, you know, what the rules are from their perspective. The permitting, is there any permitting required? Did the person get a permit if it is required? And then look at what the thoughts are for the future. Is there an OCP where they might be trying to protect them in the future? Is there interest in that? Yeah, and then I can think of a lot of things to just try and get homeowners educated and on board, you know, giving presentations or giving people to give presentations in your local area. I give presentations at naturalist clubs as much as I can, just to inform people. Like, I honestly think that for a lot of people, it's not meant in a malicious way. It's just ignorance. So the more you can just inform people, the better. Go, Neil.
Thanks, Elke. I think, yeah, I mean, everything you're saying is totally right. And I'll just sort of reiterate. From a provincial perspective, the Water Sustainability Act technically should be protecting these areas through the language they have of what classifies as a stream. So within the classification of a stream, the province has said, and this applies to private land, is that wetlands, and then they define like streams include wetlands in their legal definition, and then under the definition of wetlands, you'll see reference to seasonal ponds or something that's temporary. And so in my mind, that means that there are measures put in place at a provincial sort of blanket statement that there are protections around these types of habitats. I guess the problem being that, you know, what's on paper might not be what happens in real life. So even though they're protected on paper, what you see when you go onto the landscape is that a lot of people are just doing what they want and assuming that they can do whatever they want with private land. What I've heard from Deborah Curran, who's a environmental lawyer with the Law Center, is despite having as many tools in your toolbox as possible, we really need to shift to a culture of conservation. So I'm going to just echo Elke in saying that having a culture of people that care within your community. I mean, maybe that one neighbor doesn't care, but maybe they will feel social pressure if there's enough people around that do. And so sometimes, you know, we wear our masks or we do other things just even for social pressure. You know, so I guess, yeah, I'll just echo Elke. I don't think there's a silver bullet, but I think the more we can educate, the more we can build awareness and appreciation for the natural landscape, the better off we are as communities. Okay, so I'm going to jump into my presentation here. And just maybe if one of my team members can let me know if you can see my screen in a moment. And we'll just...
All right, I can see your screen.
Perfect. Okay. So following up on Elke's amazing presentation, I'm going to provide you with one over some of the work that we've been doing within the BC Wildlife Federation. And it's on monitoring and maintenance of some of our restoration sites from around BC. This is a photo from Earl Ranch, which is near Newgate, BC, a really small community in the southeast Kootenays. You can see the scale of this project's one of our larger ones. There's some excavators that are in the image working along. I just want to first recognize a number of funders who've helped with multiple projects that you'll see today, as well as the study, some of the monitoring study that happened as well. So Fish and Wildlife Compensation Program, Columbia Basin Trust, Habitat Conservation Trust Foundation, Environment and Climate Change Canada, the province of BC, and Wildlife Habitat Canada. So I just wanted to start this conversation around why would I be talking about restoration? Some people, there's this debate among conservation practitioners that the best thing you can do is protect. And I agree. The best thing you can do is protect. However, the case for restoration is that we have lost a lot of wetlands in BC. And here we have the lower mainland. You see Vancouver on the left and Hope is to the far right of this image. The light blue is where wetlands used to be on the landscape, just in the lower mainland. And here is what remains today. So you can see the difference between pre and current conditions of wetlands. And this kind of trend of losing a lot of wetlands between, say, 60 to 90% in developed areas is something that's happening not just in the lower mainland, but anywhere you look where there's been development occurring across both BC, Canada, and the world. There's a recent quote I saw in terms of trends of global loss of wetlands that we've lost 35% in the last 45 years. And that doesn't include wetlands that were lost prior to 1970. So I'm just building a case on why restoration and why we're looking at it. And the province currently has very minimal sort of structure around their mitigation framework for wetlands in particular. They do have a voluntary approach, which is this mitigation framework or mitigation policy, which I believe the province needs to apply, but they don't require industry or other organizations currently to follow this per se. So this leaves a lot of discretion when it comes to how restoration needs to happen if there's some sort of impact on the wetland. And so in comparison to other provinces, BC is considered to be having a failing grade when it comes to its mitigation and wetland conservation protection measures. Now, when we look at this framework here, you can see that big square. The first thing you got to start with is if you have really important wetlands, you should be protecting them and avoiding any sort of impact at all. And that's where the big protection piece comes in. It's very expensive and sometimes almost impossible to repair and restore things that have been damaged. And the best case scenario is that we're avoiding damage to some of our most important wetlands. And then from there we go to like minimizing the harm, and then in the worst case scenario, if developments are going through, having some sort of strategy for offsetting. So not only would that be for the current business model, having a good mitigation framework, but then all the wetlands that we've already lost, there's a big case for that. Now, I will mention though, doing restoration projects is not without its challenges. This is a study that was done on about 600 different other studies. So it's a meta-analysis of restoration projects. And there's different indicators as far as the success of a project goes. And you can see the top left one is on hydrologic, biological, and biogeochemical processes. And when they do these simulation analysis of how these features are recovering over time, some of them never reach that zero state, which would have been the reference condition of a natural environment. And then when you look to the right here, we have vertebrates, macroinvertebrates, and plants. The vertebrate population seems to recover, but some plant communities, macroinvertebrate communities, may not recover through a restoration project in comparison to a reference site. So there's another case for protection. Then lastly, we have phosphorus, nitrogen, and carbon, and you can see the long-term horizons for recovery on some of those aspects as well. Now, I wanted to just reference also a study that came before the one that we did, and I'm referencing it here because you might be interested in looking it up afterwards. It was a very clever project that looked at the Fraser River, near the mouth of the Fraser River, so near in the Lower Mainland. A study that looked at restoration sites that were required through Department of Fisheries and Oceans for impacts from development along the river area. And so for about 20 years, there was a program that did require offsetting for any impacts from marinas being developed and other foreshore developments. And so there was this great amount of data that the Community Mapping Network had. Unfortunately, that program closed, this compensation program closed, but all this data still existed. And what you're seeing here are all those black dots are compensation sites that were created to offset the impacts from development. What this study found was only 1/3 of these compensation sites had met 2 indicators for in terms of what the target was. And this is in retrospect, up to 20, 30 years after the project had been put in. What they were finding was that only 1/3 of the projects were meeting both a size requirement, so what that was reported as the size of the wetland that was being restored, and then the other was a native species composition, native species compared to invasive species on a site. So the reference sites, the red sites, are considered intact wetlands and were used as a measure to see, what would be the native to invasive species composition naturally, in quotations, relative to these compensation sites. And so, as I had mentioned, about only 1/3 were meeting both of those 2 objectives. So about 2/3 were failing in at least one of those measures. So that just speaks to the challenges that we have with restoration. Lots of good teams, I'm sure, were involved in some of these compensation sites, but we can reflect later on what could have been done differently, what could have been done better. So a large part of my presentation today will be talking about this study that we did, which is actually an adapted methodology from that FREMP study I just mentioned. So we looked at 26 restoration sites across southern British Columbia from projects we had done in the last 10 years, either on our own or with some of our partnering organizations. And here's a spread of where they were located around the province. You can see there's some on the east side of Vancouver Island, all the way to the East Kootenays on the other side of the province. Most of our restoration projects have occurred in the lower portion of BC, largely because that's where a lot of people live, and that's where a lot of development has happened, and where a lot of restoration seems to be most justified. So within the study, I'll just talk a bit more about that. One of the things that I'd mentioned was this native species to invasive species cover. Originally, and I guess this is something that we can maybe talk about, is monitoring and maintenance funding for projects is often under-resourced. So we can get funding easily to do the restoration project, but very few times can we find funding to do any maintenance or monitoring of a project site. Habitat Conservation Trust Foundation had offered us an opportunity to do some maintenance and monitoring of our project work, to look at, because they had funded a lot of the projects that we had done the work on, and we jumped at the opportunity to do it because we were very interested to see how well our sites were doing. And yeah, we got the money in June, which meant that we lost our window for doing the wildlife component. So that's where we stuck with just a sort of a vegetation component instead for that year. And that's another thing, is just, you know, financial budgets don't really match real world situations in terms of how wildlife likes to operate. So carrying on, what this study looked at was 1 by 1 meter herbaceous plots, as well as 5 by 5 meter shrub plots, where we had sent a team of expert botanists out with our crews as well. And they went to these 26 sites over the summer months. And they did some randomly stratified vegetation analysis. So we looked at within sort of a wetted zone, so a shallow open water zone of a wetland. We looked at the emergent vegetation zone, which would be sort of more of like a marsh type habitat. And then we looked at riparian areas that were sort of upland from that, where there had been some soil disturbance throughout the project. So we were interested to stratify among those three different veg zones to see if there was differences in between how they were recovering at a site. I should mention that a lot of the restoration projects that we have done are based off of some techniques that really focus on the hydrology and improving hydrology of sites. And we're informed primarily from support from Tom Biebighauser, who's one of our speakers and a restoration expert. So other things that we were collecting in addition to vegetation was that we did some water level readings at our sites, and we used hobo readers as well. In this case, we were using temperature hobo readers, and what we were doing was the temperature will fluctuate a lot more as soon as the hobo reader is out of the water. So the water acts as a buffer and keeps it pretty stable, but you can tell when a wetland dries out by looking at the fluctuations in temperature between day and night once it's exposed to air. So we were using that as a way of indicating when these sites were drying out, which is helpful for us in terms of things like amphibians, which need a certain hydroperiod for their tadpoles to metamorph. The other thing we did ask our team to do while they were out there, although we didn't have a robust wildlife study, is we asked them to look at incidental wildlife observations while they're out in the field. Another lens we looked at, and this ties into Elke's presentation as well, is we looked at the landscape context of these sites. We are interested in how intact were these sites, and we used we took a similar technique to what's used in Washington during some of their health assessment tools. So we scored it into 3 categories in terms of what the surrounding condition looked like. We have relatively intact areas, which show up as green here. Those intact areas are forested, grassland. You can't really see a lot of proof of disturbance, at least from satellite image. So that would be the green areas. And then there's low or medium disturbances. So this is sort of low density residential units, park spaces, moderate agriculture, where there's some form of maybe mowing or sort of land management on the site. And then there's also high disturbances. So that would be commercial or urban, industrial things that are residential units that are greater than 1 hectare or greater than 1 unit per acre. So we coded all of our sites like this and did some geospatial analysis to get an idea of what's surrounding these sites. And then we were going to compare that to some of the other observations we were making. The other thing we looked at was accessibility. So within that 1 kilometer buffer zone around our wetland, how much of that 1 kilometer is considered accessible? That's that it's not broken by any sort of road or other type of barrier that would affect land walking animals, so to speak. So amphibians are a good example. Birds obviously can get there pretty easily, but it really sort of disrupts natural migration paths for other species. So we looked at that for each of the wetlands. So some of the findings that we had were that, like just in general, restored areas had twice as many native species than pre-restoration sites. So that was good. We found that we were having a greater diversity, and then also the relative cover of our restored sites was higher than native species cover was higher in our restored sites than in our what we had as these proxy pre-restoration sites. So these were, because we only had a year to do this study, I should mention that, we selected these proxy pre-restoration sites. So we selected sites that were similar to the condition of this site prior to doing the work on them. So for instance, in Meadow Creek, we had a couple projects up there. We picked patches of reed canary grass and that had a composition similar to the sites, but that may have been adjacent to where we had done the restoration. So, but zooming in on sort of that what was doing well is remember we had this strata. So we had that aquatic, marsh, and upland riparian type of strata. We found that the relative native cover was doing really well in the aquatic zone, pretty well in the marsh zone, and quite terrible in our riparian upland zone. And so that means that where we need to focus most of our efforts in terms of maintenance ends up being this upland zone. Now, talking to the biologists and the botanists on the project, we kind of knew this going into the project, but it was good to demonstrate this through the study. When we talked to the botanists about this work, they believe the reason that we're seeing this difference is that the types of species that can come and colonize upland disturbed soils are wind dispersed often. And so that's likely why the upland zone was doing a lot poorer, was that it has a different host of species that can come and colonize the area. Whereas our aquatic vegetation, some of the things we were doing was we were removing fill, we were re-wetting areas, and then the native species that were either in the seed bank or the ones that we planted were able to recover quite a bit better. So a large portion of what we speculate is the difference here is, again, the strategies that the plants have to recolonize sites. So in terms of our marsh and shallow open water, when we look at just those sites, we have 80% of our restored sites that were significantly different. Sorry. Yeah, so 79%, this is 79% native cover at our restored sites if we just look at our marsh and shallow open water versus 14.6% at our pre-restoration sites. So the difference is strikingly different when we pull that strata out. The other thing we looked at was water depths. So we looked at how, and this had me wondering, well, is water, the more water you have in the site, likely to result in greater percent native species cover? And although our the trend line isn't terribly great. You can see that there is some indicator to this that the sites that are wetter tend to have a greater percent of native species cover in general. There's a couple sites that we went to that were bone dry when we visited them, and we were unable to get a measure of percent cover. There were 5 of them in total. 2 of them were among our lowest relative native species cover, and then 3 of them were actually high, so they had quite a bit of native species cover. However, of those 3 sites, 2 of them had some of our most intense plant maintenance costs to date. So between almost $30 to $10 per square meter were spent on those particular sites. So that might reflect why, although they were dry, they had a high percent native species cover. Why some of these sites were dry, we did this work in July and August of the year where there was a lot of fires. So it was a really dry year to begin with. And then some of these sites were constructed to be ephemeral and dry out. And some of them were created with using this liner technique. So it's a pond liner. And once that dries out, there's not going to be water around the site. Then we looked at, we were interested in, you know, how much funding should we be putting into our sites? And is the funding worth the effort in terms of cost? So we tried to get, and this was actually really hard to do in retrospect after 10 years of not necessarily capturing it the way we wanted to, was how much volunteer hours, how much time with project managers, plus the plant costs. So you could imagine trying to retrospectively follow up with some of our partnering organizations on this and get the data. It was hard to do this for all of our sites. In terms of like how much money did we spend in total per meter squared, especially if people have gone back year after year. It's really hard for them to, you know, go through their notes and see what they have in terms of follow-up and support. But we did what we could in terms of trying to estimate dollar per meter squared. And then you can see there's a bit of a line starting to happen here with percent shrub and tree cover for this instance, and the costs that we're putting in. A lot of our effort has been going into the upland area to try to deal with some of those weeds and things like that at sites. This is just as an example. This is one of our most expensive projects. You can see the density of plants we were putting in at that site. This is Dudney Elementary School, so it was a relatively small project site and a high density of planting. Which is almost at a gardening level of planting that we were doing here. In terms of our surrounding quality, like landscape quality, we were unable, at least with the plants and the sites that we had, unable to find a real trend in terms of how plants were responding to the area. So you could have a highly undisturbed habitat, relatively undisturbed habitat, and still have, you know, the data is not really showing any more percent native species composition than a really poor site. A couple things here, it might be that our strata for doing spatial analysis was not sensitive enough to pick up differences. It could also be that what we thought were native, like well intact sites may not have been as intact. The other thing is weeds tend to be able to move quite far distances in general. So there's a couple things that might be why we didn't find any trends within this particular aspect of the project. So going from that vegetation monitoring to maintenance components, just a couple things that we've learned and some of the things that we're continuing to do is we are still sending out crews to our sites, largely focusing on the restoration of upland habitat. But while doing restoration projects, there's all sorts of things that can be done to limit the spread of invasives. This is Tim Hall. He's an excavator operator, and here he is cleaning out his tractor, or his treads from any invasive species that might be from the project site before he moves on. And generally, well, always we ask that the excavators, operators are bringing clean equipment to the site, so we're not introducing new species. We do take a lot of effort in trying to remove we're trying to remove as much of the source population or of the source of any invasives on site prior to replanting. So as much time as you can put into this part of the effort is really important, is to like pre-treat your site. Couple notes on reed canary. Reed canary grass is probably one of our most problematic species. It has a really broad tolerance in its ability to live in both aquatic and upland zones, and so it also can spread really well through these runners, so through these different root systems. And even just one fragment left in the land base, you can see here, just one little fragment has a couple, like 3 new shoots coming up from reed canary grass. So this stuff, once it starts spreading into your site, really challenging to deal with. Some of the things we were looking at, this is from just one of our restoration projects. We were interested to look at the depth, what was the depth of water that we could create pools in where we wouldn't get reed canary grass coming back in. The one on the top left had the least amount of reed canary regrowth after a couple of years, versus the ones to the right and the bottom, which were shallower. So the one on the top left was between 60 and 80 centimeters deep. The ones on the top right and on the bottom were 20 to 40 centimeters deep. And you can see that reed canary grass has come back in at the site because, I mean, those roots are able to come in. The other thing I believe is happening is that the 2 sites, the one on the right and the one on the bottom, dry out throughout the year. And that drying period, I think, allows for reed canary grass to take a further hold of these sites as well. But if you get it deep enough, it can be an effective tool to keep reed canary grass out. So this is from one of our other sites where you can have these nice open bodies of water, replacing what was originally almost 100% reed canary grass in this area. A couple strategies that have come out of the literature around dealing with reed canary is to plant heavy, dense shrub species. This is Gord Gadsden on the left, providing some of our participants of a workshop with a tour of a successful site where he's managed to use a variety of shrubs and trees, using an approach that was developed, had been refined by somebody in BC named Liz Townsend, who was working in the Swan Lake area for her graduate degree, and basically had used this mulch technique and then staking it. I mean, I'm sure lots of other people have been using this technique, but Liz was one of the first that I was able to find a paper on. And Gord had used her technique at this site, and you can see it's doing quite well. It's a small little area, but you can see that it's able to outcompete the reed canary grass over time. There has been other people looking into this. This is Helen Maru from the Kwantlen Polytechnic University, BCIT. And here she is looking at different densities of live staking to outcompete with reed canary grass. So she's using hardhack or Douglas spirea. And so she has different densities, and they're doing a plot study to see, what's the optimal plant density of shrubs to outcompete with reed canary. So it'll be interesting to follow up with her on her study and see what kind of results she was finding. And here's just another image of these really small stakes she's putting in the ground. You can see some of them are sprouting with the hard hack there. She was going anywhere from, I think, if like 4 per square meter, 4 stakes per square meter to up to 64 stakes per square meter. So because of this, and because reed canary seems to be one of the species that we're dealing with a lot, we've invested a lot of time into collecting live stakes for some of our project sites. Another thing for dealing with reed canary in general, this is Monica Pearson. She's at a site that she's been leading some of the work on. This is in the Abbotsford area at a regional park. And one of the pre-treatment approaches that she's taking is to spray the site with herbicide prior to it converting into a more sensitive aquatic habitat. And this has been used quite a bit by land managers when it's in a terrestrial phase, to attempt to treat sites with herbicide to control weeds from coming in after the site is converted to a wetter site. Some of the things that we've had to deal with on a lot of our sites in terms of just the shrubs and trees is the herbivory, both from beavers or from voles that can come on the site. You can see this lovely vole guard has not done a good job at keeping the beaver away. It's really expensive to put up all the installations of these types of guards. This is quite an investment in terms of cages that were put around. We knew beaver were a big issue here, so we took it seriously and put these cages around our shrubs and trees. Happy to say they're still growing there today, and it's been one of the most successful parts of the project is to see the shrubs and trees growing in where there was just a field of canary grass. But here's a grade A example of protecting your shrubs and your trees. You can see the vole guards, you can see the beaver guards on the outside, and then you can see well, maybe all A minus. So you can see there's some plastic mulching on below. I think if it was not plastic mulching, then you get a full A plus. But this is sort of the level of detail that each of these plants and trees need to be prepared with to outcompete some of the reed canary at these sites. And as an example, you can see just in the background here, there's a bunch of shrubs between the person in blue and the person in green. There's a bunch of shrubs that are growing there. Those had that grade A treatment. So those are there because of all that work that went in. So it is a lot of work to get shrubs and trees to grow. But the nice thing is when you do that, habitat responds. So various species are able to start occupying some of these shrub and tree habitats. Other techniques that we've encountered are to paint your stakes with a latex and sand mixture. Apparently beaver do not like the taste of latex and sand and will leave your stakes alone. This is a technique that is being used by some folks in the Kootenays, and we had them try it out at a couple of our project sites. It can get pretty messy, but it is a bit more cost effective relative to to all the wiring that would be required around some of these project sites. And you can see that in this case, quite a few of the trees are regrowing the next year, doing fairly well. Here's a project that this wasn't my project, but I came across this restoration site, this one in Surrey. And after the winter time, I noticed that a lot of these potted plants and large investment and time and effort into this riparian area, that a lot of them were popping up. So that image on the bottom right, although it's a little fuzzy, is showing that the frost heaving is pushing some of the plants out. And unless the restoration team comes back, a lot of these shrubs are prone to not making it through another season. A couple strategies we've heard for that is to anchor your plugs and your plants with having a stick or like a skewer put in on a diagonal into the project site. So here we have a sedge plug And then Natasha here with the Fraser Valley Watershed Coalition is showing how she would insert a stick on a diagonal, and that holds and anchors that plant in place. So there's all sorts of things that we're learning over time that can help with the success of your project. Just little things like this. Other times we've purchased bamboo skewers to do the same thing. The benefit of using, say, a stake from a willow or something is you get 2 for 1. So you can see we have both the sedge plug growing as well as it looks like the willow has started to shoot as well at the site. I'll just talk about one more invasive species and a bit of the management around that. That's yellow flag iris. Yellow flag iris is a very beautiful plant introduced from Europe. It has floating seeds, which you can see on the top right, look like little hockey pucks, little brown hockey pucks that will float. They'll float until they find some exposed soils along the edge of a pond and then plant themselves in. On the bottom right, you can see this thick rhizome, which can become matted over time and form almost like a carpet. So this plant spreads both from its rhizomes and from the seeds, and can overtake a lot of our wetland habitat. This was a seed that was floating on the surface of a wetland we had visited, and you can see that it was ready to go. It was starting to shoot up both its roots and its shoots, just floating on the surface, waiting for some exposed soil to take place. It's hard. We had one project site where we were planning on removing yellow flag iris by hand, and then we took an entire team there. We spent about 4 hours. I exhausted our entire crew, and I think in the end we had removed maybe 1 square meter of yellow flag iris. Now, mind you, this was a really dry wetland site, which also was beneficial because the following week we were actually able to bring in a piece of heavy equipment, and all the stuff that it's clearing right now is nearly 100% yellow flag iris. You can see that it's just rolling it up like a carpet. So if you're able to, and conditions are right and permitting is in place, this is can be an effective tool in some cases to treat yellow flag iris. We've had little coming back. I know that the team, Langley Environmental Partner Society, has been removing small seedlings that have been forming around this site. But about a year later, you can see that wherever we removed the yellow flag iris, we now have these shallow open water pools. Still, mind you, you can see the reed canary grass is still present at the site around the edges. Another technique, which some of you may have encountered before, and I know she's been partnering with a lot of different organizations, is a technique that Karen Tarasoff with the Thompson River University is exploring and piloting, and that is using synthetic liners to suffocate yellow flag iris. So essentially to cut back the yellow flag iris and lay down these here she has these conveyor belt components, but she's also transitioned to using pond liners. Essentially, you cut back all the yellow flag iris, you lay down a sheet, a synthetic sheet, make sure it's anchored in really well. Sometimes that requires you to get right into the water to do. And you leave it there for about 6 months to a year. And whoops, I don't have another image of that. You leave it for about 6 months or a year, and what ends up happening is the yellow flag's response is to try to keep growing. So it ends up using all of its energy reserves within its rhizome. And although it's a very labor-intensive and costly process, it seems to be effectively removing yellow flag iris for areas that are treated. This image says it all. If you are living in cow land, how helpful just a fence can be for your project site. Sometimes that's the only thing that's required to help support the health of our wetlands is just good fences. Good fences make good neighbors. You can see the drastic difference from right to left here from one of the projects where we had a cattle fence installed. Unfortunately, I guess this is another lesson too, is that in arid areas of our province, wetlands can really shrink and expand over a decade. They can shrink and expand. And looking at historic satellite images and air photo images from previous years can really help your project in terms of understanding how large that wetland could get. When we had done the work at this site, it was only a few square meters around. And so we thought we had sufficient fencing around. This turned out to be like a small lake by the time 5 to 6 years later. So we're actually refencing this project site to accommodate these natural variations in fluctuations. Another thing is for the cattle access or cattle community and keeping good neighbors, having things like cattle access ramps or off-site watering can be really important. Here you can see a cattle access ramp that allows the cattle to come in, take a drink, and leave the site, whereas the rest of the area is just left protected by the fencing. I'm going to speak just really briefly on wildlife monitoring. This is, so as I mentioned with the HCTF project we were unable to do wildlife monitoring, but we are starting to do some of that with some of our projects now. These aren't pretty slides, so I won't leave them on the screen for very long, but it's we have been doing some point counts of birds that are coming in and using some of our sites. For this, we've had professional biologists go out and gather the data. They were able to do both bird counts as well as amphibian counts. So we had them go, these are to some of our sites in 2019. We still have to kind of do a larger analysis of what's going on here and likely need more data to make any sort of inferences on how successful our restoration projects are doing. Some of the challenges with wildlife monitoring in general is just the timing it with the biologists, because our sites are so spread apart, the cost of doing these types of surveys can be pretty expensive. Another part of our wildlife monitoring is within the Lower Kootenay, in partnership with the Lower Kootenay Band, we've been doing a fairly large project in that region, and we set up 35 wildlife cameras last spring. And in addition to these song meters, which you can see are taped to the bottom of that post there, and we set these up both at our reference sites as well as post-restoration sites. And we collected the data for this first year and are in the process of going through it. Here's an example of some of the sites that we're looking at. On the bottom, we have a couple of the restored sites, and then we have a couple of reference sites a little further north. But Kaylee, who might be on the call right now, has sent us a couple of the images of some of the wildlife that are starting to use the sites. Now you can see lots of exposed soils there. This site's going to mature over time, and so the way that wildlife responds to it might change over time. So we'll likely need multi-years of data at this site to get a really good grasp on how wildlife is using it. Yeah, just a couple of photos that we saw a couple weeks ago of some of that work. And I just wanted to end by talking about the response of wildlife to wetlands and why I still think, although restoration is not the silver bullet in terms of protecting our wildlife species, I think it's part of the mix that needs to be considered. Terry and Michelle are some of the first private landowners we worked with to restore wetlands on their property, and they so happen to be involved in wildlife photography. And so there's their house in the background. You can see some of one of the newly created wetlands in the foreground here. And shortly after their project, you can see all the the tree protectors, and then some bat boxes that had gone up and were installed. Here's an aerial image of their property, all the wetlands that were created in and around their home. And the yellow polygons show the extent of wetlands on their property. Is a few hectares in size. A cool side story here is that they were the leads in the community in terms of wanting wetlands and just loving wildlife and wanting to have more wildlife around where they lived. But following us doing the work here, they managed to convince 2 of their adjacent land neighbors to restore wetlands in their property as well. And then also the Nature Trust of BC, who has a property adjacent, you can see has also since done some work. So in total, we have 4 property owners who have done wetland work within this Meadow Creek area. Just a really cool side story. So some of the images of some of the species that are responding and coming in to the wetlands include western toad, Columbia spotted frog, some beautiful little dragonflies, bald eagle, northern harrier on the top flying there, spotted sandpiper, trumpeter swan. These swans came in literally 2 weeks after the project was created. One of the mottos that one of our restoration specialists says is, if you build it, they will come. Here's a successful hatch of mergansers, a successful hatch of American coot, some solitary sandpipers not being so solitary, a common yellowthroat, bobolink, a successful hatch of some teal, fawn enjoying a nice little bath, some more deer, grizzly bear using the site. And then lastly, this is a half-hectare wetland that was restored in 2017. This was completed during our plant vegetation monitoring. We had somebody that was flying drones for us at the time. And if you look closely at this image, there are little dots all speckled throughout this half-hectare wetland, and those little dots are waterfowl. This was from a video of the drone, so I took a still of this image and counted these waterfowl. And in this image, I counted 60 waterfowl using this area. So although we don't have our data yet on wildlife, we know that they're responding to it and that they're starting to use it. And so I think it speaks of the value of doing restoration work, although for sure protection is the key. And that's it.
So I think we have a number of questions, and I'll just leave it to Molly to convey those for you.
We do. We got a lot of people curious. The first question we have is there a map showing the Shuswap Okanagan historical wetland areas, like the one you showed for at the beginning of the presentation?
Yeah, there's, I didn't put it in this slide deck, but I do have a map of the Okanagan at least. There's a biologist named Ted Lee who did an analysis of riparian shrub, swamp habitat, and wetland habitat from basically Soyuz up to maybe Vernon. I can't quite remember the exact extent, but it's fascinating because you can see where all the wetlands have been lost is basically where all the communities are. And then the wetlands that are remaining are really small and really hard to see on the map. So there's these big swaths of sort of this floodplain wetland habitat that were removed from agriculture and then other settlements over time. And so in the Okanagan, I think we have probably the greatest loss of wetlands. I think it's close to 90% in some areas.
Okay, thank you. The next question was from Elke, and she asked, what were used for the proxy re-restoration references? Which ones did you use? Yeah,
so that was challenging. We had, I essentially had to, by memory, put points on a map for our team to go out into the field and use as data points. It was easy to do for vegetation because it's you could have the sites right adjacent to your other projects as long as it wasn't where the disturbed soil was, and get a fair, like as long as the hydrology hadn't changed at that site, it would mimic pre-restoration sites, at least for, and so I tried to be as selective as possible in if I wasn't sure, not picking those sites, but we knew that, you know, there, for instance, at that Halloran farm, which you'd seen, there were areas on his property where we didn't touch, and we were pretty sure that no hydrological changes had happened. So I had put points on the map and said, go there and do veg monitoring there, because that looks exactly like what we had. It's not ideal. I mean, the study design isn't ideal. Ideally, you'd be getting this vegetation information prior to doing the restoration project. This was, as you can see, this was like a like we had so many different projects, and we just didn't have that data for all of our sites. And so this was the best we could do in the time frame that we had.
Our next question is, what native species did you monitor? Only plants, animals, fungi, etc.?
So we were looking at plants particularly. We had botanists. We had 3 botanists that were regional. So we had one that specialized sort of on the coast, one that was familiar with the Kootenays, one who lived on the coast but was familiar with the Okanagan and did the work sort of in the more arid regions in between, sort of Thompson, Okanagan area. And yeah, so we focused on plants for a lot of our study, not so much the other species. So they were asked to provide lists of like just incidental lists as they're walking into the site, but then focus on these randomized plots that were within the wetland. And they were upwards of 25 to 30 random plots in every wetland that we visited. And that was so then we could gather mean and standard deviation when we were trying to figure out percent native to invasives and have like enough of a data pool so then we could run some analysis.
Thank you. Next question is, does funding include the value of volunteers in their work?
Yeah, so if we knew there was a planting party, like a volunteer planting party, if we knew that happened, we would try to integrate that into the value. And then we put in, for volunteers, I think we picked minimum wage, just as far as like something that was conservative in terms of the value of their time. The challenge for us was that some of these like, it's always in retrospect that you realize the data that you want to be collecting. And also because we have partners that were the leads on some of these projects, sometimes, you know, it's not the greatest time of the year to be asking them in June and July if they can send us a bunch of data. That would be more of a winter project for them. So some of our projects we weren't able to do that analysis on because we just didn't have that information. But yeah, if we knew, volunteers would be counted that way.
Okay, thank you. Is there a number of time, Sarah asks, is there a time, and then in brackets, number of years to keep the water deep until reed canary grass is killed off? Or will it come back if that water is lowered later? My question comes from one of their guidelines to encourage ephemeral wetlands in order to reduce bullfrog populations. Mm-hmm.
Yeah, that's a really challenging thing, I think, for like people that live in the lower mainland, especially where bullfrog were on the east side of Vancouver Island. Yeah, there's a lot of best management practices in terms of creating these ephemeral ponds to limit bullfrogs from occupying the sites. But yeah, it's a trade-off, right? If you have reed canary still sort of on the edges or the perimeter of your site, there is a chance that it will come back and start to take over your site if it becomes ephemeral. I think when the deeper the water, the more permanent, the better for reed canary, but not so much for controlling bullfrog. So, you know, I guess on the flip side, if you can manage the amount of water that's at your site, you know, if it can dry out just for a couple of days and that kills off the bullfrogs, but doesn't allow the reed canary to come back, that might be an option, but that's not always going to be the case.
Okay, thank you.
Sorry, Molly, before we move on, Barbara, who asked the question about the map of the Okanagan, she just had to step away when you spoke of the study. Can you just repeat who did that study?
Yeah, that was Ted Lee, and it was through this biodiversity, oh, I can't remember what the publication was called. I do have an image of the, I can send off afterwards, of the like overview map. It does, I don't know if it includes the Shuswap though. I think it just includes like the Okanagan area.
Okay. Thank you very much for repeating that. The next question comes from Jan, and she says, do you have to remove beaver baskets eventually? It says 10 years into the project, or can they be left there forever or longer?
I mean, I don't think there's, I mean, ideally, I'd like to see those baskets removed at some point. I think you kind of want a healthy enough population of shrubs to do well on their own without the impacts of beaver. Sometimes beaver can be like, they can really mess things up for some restoration projects. So, you know, it might be the day you remove it that is they come back in and clear out what you're doing. I mean, in my mind, I'd love to say that you could pull them out once you have a healthy, robust shrub zone that can tolerate some browse. And it might be that you just want to monitor your site and see, keep track and maybe just remove some at a time and to see how much they're getting browsed. We haven't removed them from our sites yet, but that is a good question.
Okay, thank you. The next one is from Sarah, and she asks, what are the maintenance efforts look like for vole guards and beaver wiring? Do you have to constantly readjust them as the stakes grow? Also, are there any concerns for bamboo spreads when you're using bamboo anchors and stakes?
Right, yeah, so for the first part of that question, maintenance effort, like you could see in the images we had that we had left a really broad diameter around our shrubs that we were growing, so we wouldn't necessarily have to go back and adjust. And then those vole guards kind of are twisty, so they'll kind of open up as the plant diameter grows. So I would say it's pretty low in terms of having to go back and deal with them afterwards. There's always a chance that they weren't installed properly, and you know the voles could get in and still chew them down, or the beaver might, you know, if something lifts up, then the beaver might be able to tuck under and get at the plant. So you'd want to check on that. In terms of the bamboo stakes that I had mentioned, they weren't live bamboo. It was like almost like a tree, like bamboo skewers you'd get for doing your barbecue. So they were like quite dry, and I do not believe those things can spread. Yeah, we were buying like dollar store, you know, those little brown things that you normally soak. I think they're pretty dead.
Okay, great. We're coming up pretty close to 12:30, so depending on your schedule, we might only have time for maybe one more question. Neil, do you have time to answer? We have 6 questions waiting. Do you have time to answer a couple more, or do you?
Absolutely, yeah, that's fine. Yeah.
Fantastic, then I'll just keep going through them. Okay, the next question is there any assessment of water chemistry change before and after restoration? If not, do you know of any literature or studies you can refer about water chemistry change?
Personally, no. That one study that I'd mentioned with that meta-analysis one that was done in 2012, it did have some, let's see if I can pull it up here. Moreno Mateus et al. they did have some chemists, they had phosphorus, nitrogen, and carbon that they were monitoring. And so they would have referenced some restoration project study sites. I'll just copy this and put it in the chat. So I'd maybe if you're trying to find the first part you could do is maybe look at that study, look at their references for chemical analysis. We haven't done a lot at our sites though. So I just dropped something in the chat there. Is there another question, Molly?
Yep. Okay, the next question is, how long would you monitor yellow flake iris that's been under a pond liner for, say, 6 months or something like along that timeline?
Yeah, so, and I mean, I really owe credit to Catherine, and I think somebody had put in the chat or the comments box that she does do workshops on this too. But what she's looking for is to see if the rhizome has died. She'll break it open, and often they'll turn like a black or like really dark brown once they've died. And they'll get kind of mushy and spongy. Whereas if they're still alive, they'll be a bit more rigid. The color won't be as brown. So you're looking for that when you're before you're peeling off the layers. Okay,
thank you. The next question is from Rich, and he says, can you please recommend control measures for ponds that are covered 100% with Azolla during spring and summer?
Yeah, I haven't dealt with Azolla myself, so I don't know for sure. I think it might be a nutrient issue. I think Azolla and things like even duckweed, which is a native species, I mean, they can tend to occupy sites that have lots of nutrients. If you can find the source of that, you might have it might be somewhat helpful. Typically speaking, when people talk about pond maintenance, they suggest removing leaf litter in the fall. If you're trying to, if it's an aesthetic thing, remove leaf litter and other things that contribute to nutrients over time. But if there's another source that's coming in, then obviously try to block that. I don't have much more to say about that though, in terms of Azolla.
Okay, the next question is actually there's two questions from Nicola. What is the order of magnitude of cost for monitoring one site? And do you have any documentation on the Halloran success?
Yeah, so I'll start with the first question. So some of our larger, some of the reason that some of our sites had such a high dollar per square meter was that they were small. We had a lot of effort we could put into this small space, whereas some are these massive areas, and we just couldn't justify spending that much on that large of an area. For example, a hectare is 100 by 100 meters. That's 10,000 square meters. So if we had to pay $30 a square meter on a hectare project site, that would be astronomical in terms of the cost for effort. But our ranges in what we think was our range of cost per square meter was anywhere from $1 to $30 per square meter. And then the other part in terms of the Halloran restoration, we don't have anything specific on Halloran, like the wildlife photos that I had sent, those were sent to us from the property owners. They were part of the study though, so the maintenance and monitoring study that I talked about today for vegetation, and we can circulate that if people are interested in terms of that report and what it found. It kind of masks everybody's project, so it just pulls it all together, but we can share that.
Perfect, thank you. And I think Elke had some comments about one of the questions as well, if she wants to unmute herself. Thank you, Elke.
Yeah, I just had a couple comments. One was around the depth and concern around bullfrogs. That you should be aware of where you are in the province relative to where bullfrogs currently occur. And if you're outside of the range of bullfrogs, then you can manage your depth whatever way you'd like. If reed canary grass is a concern for you. The second one was around the bamboo. I use bamboo, the really tall bamboo stakes for gardening to hold my water level gauges. And I did notice one send some shoots out of one of the nodes, and it was outside of the water where the shoots were coming out. So I guess there's always a potential it could start to sprout if you use it, but that would just be one more thing to add to your monitoring.
Yeah, thank you. Appreciate that. I didn't, I thought it was dead, but maybe not so much.
Yeah, me too. I would have thought so too.
All right, and that is it for questions.
So I've just added in the chat, I added a link. We do have an evaluation form available. This is the first time we are hosting a webinar series, so any and all feedback is much appreciated to make sure we are able to provide usable information in the future, and the format is one that's kind of user friendly. So if you could take the time, it's just 5 questions, so if you could take the time to fill that out for us, that would be much appreciated. We'll also be sending the link in a follow-up email, and I've also just added a link of the upcoming Institute speaker series that we have as well. I think we have 3 more events throughout the remainder of the year, so you're welcome to participate with us in the future. I just want to take one more opportunity to thank our guest speakers, to thank Elke and Neil for taking the time out of their day to join us today, and thank you everybody for having such in-depth and engaging questions. I know that some fellow participants had a lot of good information in the chat, so please make sure to take a peek at the chat really quickly. I know Paige with the Habitat Acquisition Trust has added some good information. So again, this is an opportunity to collaborate with each other and share knowledge amongst each other. So please take the opportunity to do so. And if you have any questions for us or Neil or Elke, we'll be sending their contact emails in the follow-up email. So once again, thank you all. If you have any further questions, please feel free to email us.
Sorry to interrupt, Alyssa. We actually just had one more question come in. If you don't mind us answering it before we end today.
Sure.
This last question comes from Sarah. She wants to know if private property owners pay the majority of the restoration efforts.
Can you guys hear me?
Yes. Yeah, we can.
Okay. For the projects that we've done to date, the landowners, we didn't charge them funding. It was pretty new for us as an organization to be doing work on private land, and we did have at the time we had a pretty good pool of funding from the federal government, which no longer exists. There was this National Wetland Conservation Fund. But what the landowners do provide is their volunteer time on the project, as well as the space, which could be converted into another use. However, going forward, we've been approached by a number of landowners, and what they're able to contribute financially may play a role in our decisions on what we're able to do. Because I think there's more property owners than funding available from any sort of grant to do a lot of the work. So I think landowners would, if they're able to come with some funding, then that can certainly help in terms of prioritizing or decision-making on which project goes forward. They can be expensive to do. Protection, again, is the best thing, but yeah, thanks.
Great, thank you so much. I think we will call it for today. I think we had originally said we would end at 11:30, so we're just after. So thank you once again for joining us today, and make sure to fill out the evaluation form and come join us for future webinar series. Have a great day, everybody.